All right, let's consider this problem. It says solve, and the original problem is 16x cubed minus 54 equals 0. So in a problem like this where we're solving, what we want to do is try to factor it first. So notice that I already factored out a 2. That was the greatest common factor. So I would say this, always factor out the greatest common factor if the problem has one. So there's a 2 that we could take out here. And if we do that, notice what's left over, this. When you look at these numbers, you should be thinking, hey, those are perfect cubes, because in the factoring methods, one of the things we look for when we have a problem that has two terms is, are these perfect cubes? Well, I know that 2 times 2 times 2 is 8, and I also know that 3 times 3 times 3 is 27. So I kind of recognize this as a difference of cubes right off the bat. Might take you a little bit of time to come to that conclusion, but not me. So anyway, so when I look at this and realize it's a difference of cubes, what I want to do is go ahead and set this 2 up here. When you have a difference of cubes, I would say set up a short set of parentheses that are going to have 2 blanks, and then set up a large set of parentheses that's going to have 3 blanks. In this first blank, you want to put why is this a perfect cube, or what is it that makes that a perfect cube? And I would say that's going to be 2x. So 2x times 2x times 2x is 8x cubed. And then over here, I'm going to put 3 because 3 cubed is 27. Now, this sign is always the same as that one, so you can actually factor a sum or a difference of cubes, but this is going to be minus because that is. Now, I always tell my students that this has little to do with what's up here. This is going to come from here. So I would take this in stages. We factored out the GCF, and now I've broken this down into this part, and now I'm going to complete this using these terms. So this blank is that one times itself, which is going to be 4x squared. And this blank is going to be those two things multiplied together without their sign, that is. So that's going to be 6x. So 2x times 3 is 6x. And this sign is always the opposite of what you find here. So this sign, this sign is the same as that sign. This sign is going to be the opposite of that. And then the last sign is always addition. So this, I know this is going to be addition because it always is. And this blank is that term times itself, that term squared. So I'm going to have that. So this is what I have. Once I factored this out, I have this crazy looking factored form for this. So I factored it out. Now I don't, since I'm solving, I need to go ahead and figure out what x has to be in order for this to be equal to 0. I don't have to set the 2 equal to 0 because this doesn't have a variable on it. But I do want to do the 2x minus 3 equals 0. So solving this, of course I'm going to add 3 to both sides. I end up getting this. And I'm going to divide by 2. I'm going to get 3 halves. Now, this other one is, it doesn't look like, if you look at it carefully, it does not look like it's going to factor. In fact, it's not going to factor, which means I'm not going to do it on this video because I want this to be short, but I would just simply say this. We're going to have to solve this by the quadratic formula. So you might want to look up another video on, how to solve a problem using the quadratic formula. So it is a quadratic and it's not going to factor. So we're going to need to use the quadratic formula on that. And I'm not going to do that on this video. But if you do, you're going to get 2 other solutions. So there's one solution here, and we would get 2 other solutions from this. And like I said, you're just going to have to look that up on another video. Like if you go to YouTube and you type in how to do the quadratic formula, you'll see a bunch of videos out there on how to do that. And I might even have one on my site, not sure. At some point I'll do this, but not on this video. All right, see you later. That's how you solve that.